Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's presentation on random variables and probability distributions, part 4. Coming to the last session, we have discussed measures of central tendency, the definitions of mean, median, mode, variance and standard deviation, and some problems on probability distributions. Now, today's presentation deals with the discrete random variables and discrete probability distribution. So, we will discuss some problems on discrete random variables and discrete probability distributions. Now, the problem number 3. A random variable capital X has the following probability distribution. So, the probability distribution is given here. The first row denotes the values of X and the second row denotes the values of corresponding probabilities. So, here X takes the values 1 to 8. So, total number of values 8, which is finite. So, it comes under discrete probability distribution. And corresponding probabilities are given in terms of an unknown K. Here the value of K is unknown, but the probability is given in terms of K. So, when X equal to 1, the probability is K, X equal to 2, probability is 2K and so on. And the question is to find the value of K first, then find the probability of X less than or equal to 2 and X lies between 2 and 5, 2 including and 5 excluding. Here in discrete case, this less than or equal to is not same as less than. These two are not the same. Whereas in continuous case, less than or equal to and less than are the same, as X takes the infinite number of values. But here strictly less than means excluding that value. Less than or equal to is including the value. Now, coming to the solution, in the first problem, we need to find the value of unknown K. So, the first one can be obtained using the property, the total probability is always unity. The total probability is always unity. That means sigma pi is equal to 1. So, if you add all these probabilities like K plus 2K plus 3K and so on, 5K, 6K, 7 and 8, this total must be equal to 1. So, by adding all these values, 36K equal to 1, that implies the value of K is 1 by 36. So, we have obtained the value of K using the property the total probability is unity. Now, we can rewrite the distribution, we can replace this K by 1 by 36 and then we can evaluate the remaining two, the probability that X less than or equal to 2 and X lies between 2 and 5, 2 including. Now, coming to the second problem, probability of X less than or equal to 2. Since we are dealing with discrete probability, here less than or equal to means including the value 2. So, here less than or equal to, there are only two values. This is equal to probability of X equal to 1 plus probability of X equal to 2, since less than or equal to 2 is there. So, K plus 2K, which is 3K, but K is 1 by 36. So, the answer is 1 by 12. The probability of X less than or equal to 2 is 1 by 12. Similarly, we can find the next one, the third one, probability of 2 less than or equal to X less than 5. So, that means 2 includes here probability of X equal to 2 plus X equal to 3 plus probability of X equal to 4, less than 5, strictly less than. So, 5 excluded here. Now, X equal to 2, 3 and 4, 2K, 3K and 4K. So, 2K plus 3K plus 4K, total 9K. So, 9 by 36, since K is 1 by 36. So, the answer is 1 by 4, 0.25. 2 less than or equal to X less than 5. Similarly, if the problem is to find the probability of 2 less than or equal to X less than or equal to 5 is also given, then we will add 5K also. In this problem, it is given strictly less than 5. Hence, the answer is 0.25. Similarly, let us discuss another problem. A random variable capital X has the following probability distribution. So again the discrete probability distribution is given as x takes values 0 to 7, total number of values 8. And the corresponding probabilities are also given in terms of the unknown k. So here if you find the unknown k, we can find the probabilities numerically. And the first question is to determine the value of k. So let us start with the same property as the total probability. We know that the total probability is always unity, sigma pi is equal to 1. So if you add all these values, so 0 plus k plus 2k plus 2k, 3k, then k square, 2k square, 7k square plus k is equal to 1. And here k square, 2k square, 7k square, total 10k square, and 1 plus 2, 3 plus 2, 5 plus 3, 8 plus this one 9. So 10k square plus 9k equal to 1, which is a second degree polynomial in terms of k, a quadratic polynomial in terms of k. So it has two roots. By finding the roots of this, by writing it in factors form, we get is equal to 0. So 10k minus 1 equal to 0, or k plus 1 equal to 0. If k plus 1 is 0, what will be the value of k? Minus 1. If k is minus 1, then the corresponding probabilities will be negative. But we know that probability always lies between 0 and 1. The minimum value is 0 and the maximum is 1. It cannot be negative. So we cannot take k equal to minus 1. So using the first one, 10k equal to 1 and k equal to 1 by 10. So k, the value of k is 1 by 10, or simply we can use 0.1 also. So using the property, the total probability equal to 1, we can find the unknown value given in the probability distribution. Now the second problem, x greater than or equal to 6. The second one, probability of x greater than or equal to 6. And here the values of x are from 0 to 7. Greater than or equal to 6 means these two come 6 and 7. So probability of x equal to 6 plus probability of x equal to 7. And what is the probability of x equal to 6? 2k square, 7 is 7k square plus k. So 2k square plus 7k square plus k. So total 9k square plus k, with k equal to, where k is 1 by 10, which is 0.1, the final answer is 0.81. So probability of x greater than or equal to 6 is 0.81. Now the third one, probability of x less than 6, strictly less than 6. Less than 6 means all the values of x which are less than 6 we need to consider. So that means 0, 1, 2, 3, 4, 5, sum of all these probabilities. Instead of finding, or instead of adding all these values, let us use the property that total probability is 1. Total probability is always 1. So we can write this as 1 minus probability of x greater than or equal to 6. So probability of x less than 6 is 1 minus probability of x greater than or equal to 6. Just now we have calculated probability of x greater than or equal to 6. So 1 minus 0.81, which results as 0.19. And the probability lies between 0 and 1. And our answer must be between 0 and 1. And coming to the fourth one, we need to find the mean of the probability distribution. So to find the mean of probability distribution, mu equal to expectation of x, which is sigma xi into pi. So if you add all such values, xi into pi, 0 into 0 plus 1 into k, k is 1 by 10, 2 into 2 by 10, 3 into 2 by 10, and so on. So by finding the sum of the products, we can calculate this value, sigma xi into pi. This is 0 into 0 plus 1 into k plus so on, plus the last value is 7 into 7k square plus k, sum of the products of those values. So finally this results in the form 66k square plus 30k with k equal to 1 by 10 or 0.1. So, the final answer is 3.66. Mu is 3.66. Similarly, we can calculate the variance of the distribution. The formula is sigma square is expectation of x square minus expectation of x whole square. Expectation of x is just now calculated as 3.66 and we need to calculate this expectation of x square which is sigma xi square into pi minus 3.66 whole square. So, if you calculate this sigma xi square into pi is just square the elements of x and multiply it with corresponding probability plus 1 square into k plus so on 7 square into 7k square plus k. So, if you find this, simplify this, then we will get 440k square plus 124k. So, this is 440k square plus 124k minus 3.66 whole square. So, after calculating this, we will get the final answer as 3.4044. So, the variance can be calculated using the formula expectation of x square minus expectation of x whole square. Expectation of x is calculated in the previous problem and now expectation of x square using this sigma xi square pi can be evaluated and hence we can find the variance. Now, the next one is find the probability distribution function. So, the probability distribution function means the cumulative probability we need to calculate. The probability distribution function. So, that means we have the values of x given from 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7 and this capital F of x probability distribution function or cumulative probability function is probability of x less than or equal to x. So, first this one probability of x less than or equal to 0, the answer is 0, the first value. Now, probability of x less than or equal to 1, less than or equal to 1 means there are two values 0 plus k which is 1 by 10, the answer is 0.1 and probability of x less than or equal to 2, 0 plus k plus 2k which results as 3k. So, 3 by 10 which is 0.3 and probability of x less than or equal to 3, 0 plus k plus 2k plus again 2k 5 by 10 because the values are given less than or equal to 3 means 2k, 2k, k, 0. We need to add all these 4 values. So, 5 by 10. Similarly, x less than or equal to 4 is 8 by 10. X less than or equal to 5 results in the form of 81 by 100. X less than or equal to 6 because the last probabilities are given in terms of k square. So, we will get k square terms here. Hence, the value is 83 by 100 and x less than or equal to 7. Since 7 is the last value, sum of all probabilities, the total probabilities must be 1. So, the last value is 1. This is the probability distribution function of the given distribution. So, capital F of x, the cumulative probability function in which we calculate the sum of the probabilities. And the next problem is find the maximum value of x such that find the maximum value of x such that the probability of capital X less than or equal to x is greater than 1 by 2. Capital X less than or equal to x must be greater than 1 by 2. So, we need to find this value of small x in which that x must be the maximum value and probability of x less than or equal to that particular point must be greater than 1 by 2. So, to find this we can use the previous distribution, probability distribution function. You see here x less than or equal to 0 is 0, less than or equal to 1 is 0.1, less than or equal to 2, 0.2, 3, 0.5, whereas here 8 by 10 is 0.8, which is greater than 0. So, probability of x less than or equal to 0 is 0, which is not greater than 1 by 2. X less than or equal to 1 is 1 by 10, 0.1, which is not greater than 1 by 2. X less than or equal to 2 is 0.3, which is not greater than 1 by 2. Similarly, for 3 also we are getting 0.5, which is not greater than 1 by 2. We must get the probability more than 1 by 2. So, x less than or equal to 4 is 0.8, which is greater than 1 by 2. Therefore, the maximum value of x such that this condition holds is x equal to 4. If you take x equal to 4, this condition will be satisfied. Today's session, we solved two problems on probability distribution function and probability discrete probability distribution and discrete probability random variable. In the next session again we will solve some more problems on the same, the discrete random variable and discrete probability distribution. Thank you.